All right, welcome back everyone. This video covers the test review on radians, arcs, sectors, and volume. All right, at number 1, we want to find the volume of this figure. This figure is a prism with a triangular base, and the length of this side right here is 6 because it matches the length of the side on the top. The volume formula is the area of the base times the height. And the area of this triangular base is 1/2 of 8 times the 6. And the height is this 8 here. We multiply that out, we end up with 192 cubic feet. That is the answer for number 1. All right, find the volume for number 2. First, we recognize that we have a prism with a rectangular base, and this side here is going to be 12 because it matches the side length 12 here. It is a prism, as we said, and the volume of a prism is the area of the base times the height. The base is going to be multiplying the 7 times 12, and we have a height of 11. And you multiply that out to get 924 cubic inches. All right, here's number 3. We want to find the volume, and this is a sphere, and the volume of a sphere is 4/3 times the radius cubed times pi. The radius is 5, so we do the 5 cubed in the formula. And then when we multiply 5 cubed times 4, we get 500, so that'll be 500 over 3 as a fraction, times the pi. And we can leave our answer like this, or if we multiply everything out including the pi, we get the 523.60, and this is kilometers cubed. All right, number 4, we want to find the volume of this figure. This is a pyramid with a triangular base, and the formula is volume is 1/3 the area of the base times the height. Now the base is a triangle, and to find the area of that triangle, it's 1/2 of the 3 times this side here, 4. So it's 1/2, 3 times 4 gives us the area of the base. The height is 9, so that's times 9 there. And when we multiply all of this out, we end up with 18. So the volume is 18 cubic yards. All right, for number 5, we want to find the volume of this figure. And this is a pyramid, and the formula would be 1/3 area of the base times the height. The base is a square, which is 6 by 6, so the area is 6 times 6. The height of the pyramid is 10, and we multiply by 1/3, and when we multiply that out, we get 120 cubic inches. All right, here's number 6. The volume of this figure the formula is volume is 1/3 times the area of the base times the height because it's a pyramid. The pyramid has a rectangular base, so the area of that base is 6 times 5, which we have here, and the height is 4. Multiplying all of this out, we end up with 40 cubic centimeters. All right, here's number 7. The shape is a cone, and the formula is 1/3 area of the base times the height. Now the base is a circle, so we have to use the circle formula, which is r squared pi. That is the area of a circle. Now the radius is 11, and the height is 22, so we have the 11 squared pi here times the 22 on the outside. If you multiply everything except for the pi, that is 22 times 11 squared times the 1, you're going to get 2662, and then that'll be over 3. So it's 2662 thirds times pi. If you want to include pi in your calculation, then you have 2787.64 cubic miles. All right, let's find the volume for number 8. We do have a pyramid, and the formula is 1/3 capital B times H, which is the area of the base times the height. All right, the base is a square, which is 8 by 8, so we multiply the 8 times 8. Our height is 7, so we have the 7 there. And when we multiply all of this out, we get 149.3 repeating, and that's cubic meters. All right, we're finding the volume of this figure, and this is a cylinder, and the volume of a cylinder is the area of the base times the height. The base is a circle, so that is radius squared times pi, and the radius is 6. And the height is 7. So we plugged in the numbers here, 6 squared pi times 7, and we get 252 times the pi, and then if you want to include pi in your calculation, it'll be 791.68, and it's cubic kilometers. All right, we want to find the volume of this figure. It is a sphere, and the formula is 4/3 times the radius cubed times pi. And the radius is 8.4, so we plug that in. And then this would go into our calculator, and we would end up with 790.272. That's without the pi. So it'd be 790.272 times pi. And then if you include the pi in your calculation, it's 2482.71 cubic meters. All right, the volume for problem number 11. We recognize that we have two different shapes. We have the first shape, volume 1, would be a half cylinder, and for volume 2, the shape on the bottom, that would be a rectangular prism. First, we look at the volume of this half cylinder. And the half cylinder would be half of 6 squared times pi, where 6 is the radius. That's because the diameter is all the way across, which would be 12. That makes the radius of that circle 6. So we put in 6 squared pi. That gives us the area of the base. And the height is along this side here, and that would be the 25. And then we're multiplying it by half because it is half of a cylinder. When we multiply that out, multiplying everything except for the pi, we get 450 pi. Now for the figure on the bottom, that's a rectangular prism, which is capital B times H, the area of the base, times the height. The base is 12 by 25, so we multiply that, and the height is 8. So that's 12 times 25 times 8 is going to give us 2,400 cubic feet. Then to find the total volume, we add the two volumes together. And that's going to be the 450 pi from the top plus the 2,400 from the bottom. And when we put all of that in the calculator, we get this 3813.72. Either answer is acceptable. All right, we want to find the volume of this figure in number 12. We see that we have a cube here, and then it looks like there is a cone that is cut out. So it's the volume of the cube minus the volume of the cone that has been cut out. Now the volume of the cube is area of the base times height, and the volume of a cone is 1/3 of r squared pi, that's the area of that circle, and then times the height. Now the base of the cube is 6 by 6, so that's 6 times 6, and the height is also 6. The radius of this circle is 2, so we put in the 2 squared there, and the height of the cone is also 6, so we have 6 here in the formula. Multiplying all of that out, 6 times 6 times 6 is 216. And if we multiply the 1/3 times 2 squared times 6, we get 8, and then times the pi there. So that is a sufficient answer. And if we want to go all the way and multiply everything out, including the pi, you get 190.87 cubic centimeters. All right, number 13. It looks like this figure is a cone that is stacked on top of a cylinder. So the volume would be the cylinder's volume plus the cone's volume. The first thing we want to do is figure out what this height is, and we can use the Pythagorean theorem by saying that this 5 squared plus the height squared equals the hypotenuse of 13 squared. And when we solve for h, we end up with h squared is 144, so h would actually be 12. So the height of the cone is 12. Now, the volume of a cylinder is the area of the circle times the height of the cylinder. So the area of the circle is 5 squared, because 5 is the radius, 5 squared pi, and times the height of 2. That covers the cylinder. And then the volume of the cone is the 1/3 area of the circle multiplied by the height of 12. And again, the circle's radius is 5, so we have 5 squared pi times the 12 there. The cylinder comes out to be 50 pi, and the cone, when we multiply all of this out, comes out to be 100 pi. 50 plus 100 is 150 pi, and that would be an acceptable answer. If we want to include pi in the calculation, it's 471.24 cubic centimeters. All right, here's number 14. Looks like we have two figures on top of each other. On the bottom, we have a rectangular prism, and on the top, it looks like we have a trapezoidal prism. So to find the total volume, we find the trapezoidal prism's volume and the rectangular prism's volume and add them together. Now here is the formula to find the area of a trapezoid. That's 1/2 base 1 plus base 2 times the height. And base 1 of the trapezoid would be the 5 across the bottom here, and base 2 would be the 2, and the height of the trapezoid would also be 2. So for the trapezoidal prism, we would have, using the trapezoid formula, 1/2 5 plus the 2 times the 2. That gives us the area of the base, and then the height of the entire prism is 6. All right, for the rectangular prism, we have a rectangle that is 5 by 6, so the area of the base is 5 times 6, and the height of that rectangular prism is 3. So that's 5 times 6 times 3. All right, multiplying all of this out for the trapezoidal prism, we get 42, and the rectangular prism multiplied out is 90, and added together gives us a final answer of 132 cubic centimeters. All right, here is number 15, and it looks like we have a cylinder. The challenge here is that we do not know the radius of this cylinder, and we do not know the height. So what we can do is we can create this right triangle here. I'm going to call x the length of this diameter, and h, of course, would be the height. And it was given that this angle here is 37, so I just wrote that inside there. Now we can use SOHCAHTOA because we know that this x here is the opposite side of the angle 37, and 14 is the hypotenuse, and opposite over hypotenuse is sine. So we can say that the sine of 37 is x divided by 14. And then solving for x, we would just multiply by 14 on both sides. So x is 14 times the sine of 37, which is the 8.425. Now that is the diameter, so the radius would be half of this 8.425, which is 4.2125. All right, that's our radius. We can also find the height using SOHCAHTOA. The height would be considered the adjacent side of this angle 37, and 14 is the hypotenuse. So the cosine of 37 is adjacent over hypotenuse, or h over 14. Multiplying by 14 on both sides, we get h is 14 times the cosine of 37, which comes out to be 11.181. Now we have all the ingredients to find the volume. Volume is the area of the circular base, which is the radius squared times pi, or 4.2125 squared times pi, and then times the height. And that height is the 11.181. Multiplying it out without the pi is 198.409 times the pi, or including the pi, is 623.319, and that is in cubic inches. All right, here's number 16. And in order to find the volume of this cylinder, we would need to find the height. Now this slanted side right here is 5. And because that is 5, that means we can carry that 5 over to this side as well. Now this creates a right triangle where the height is here, the 3 is on the bottom, and 5 is our hypotenuse. So we can put those into the Pythagorean theorem and figure out h. So 3 squared plus h squared equals 5 squared, which means h squared is going to end up being 16, which means h is 4. Now, based on Cavalieri's principle, the volume of this cylinder, even though it is a slanted cylinder, is still area of the base times the height. The base is a circle with a radius of 2, and it has a height of h, which was 4. So we put the numbers into the formula, and the volume is 2 squared times pi times 4. Multiplying everything except the pi, we get 16 pi. And then if you include pi in the calculation, it's going to be about 15.265 inches cubed. All right, here's number 17. It says solid A is similar to solid B with a height ratio of 4 to 5. If the surface area of solid A is 70 inches squared, what is the surface area of solid B? Well, first, we recognize that the height ratio is 4 to 5, or 4 over 5. And we know that the surface areas ratio would be 4 squared to 5 squared. 4 squared is 16, and 5 squared is 25. So the surface area ratio would be 16 to 25. And now we can set up an equation using proportions. We know that 16 to 25 is equal to 70 to the larger surface area B. So then we cross multiply, and we get 16 times B is equal to 70 times 25. And 70 times 25 is 1750. Then we just need to divide by 16 on both sides. So B, the surface area of solid B, is 109.375 inches squared. All right, number 18. A side length of solid F is 3 feet, and the corresponding side length of solid G is 7 feet. What is the volume of solid F if the volume of solid G is 254 cubic feet? So the side length ratio is 3 to 7, because solid F has a side length of 3 and solid G has a side length of 7. The volume ratio would be the cubes of both of these numbers, 3 cubed and 7 cubed. So the volume ratio is 3 cubed to 7 cubed, or 27 to 125. So now we can say the smaller solid F divided by the volume of G, 254, equals the ratio of 27 to 343. Now if we multiply or cross multiply, we'll get 343 times F, or X, equals 6858. And so that means F, or X, is equal to 19.994 cubic feet. All right, here's number 19. The volume ratio of similar solids P and Q is 9 to 8. Given that the perimeter of the base of Q is 45 centimeters, what is the perimeter of the base of P? First, we acknowledge that the volume ratio is 9 to 8, and then we would have to take the cube root of those volumes to figure out the perimeter ratio, because perimeter is one-dimensional, whereas volume is three-dimensional. So we take the cube root of this 9 over 8 to find the perimeter's ratio. So that is the cube root of 9 over the cube root of 8. Now the cube root of 8 we know is 2, but the cube root of 9 is a decimal, so we'll just leave that as cube root of 9. Now we can use this ratio and in a proportion to solve for P. That is the volume of P. So the volume of P, the perimeter P divided by 45 is equal to the cube root of 9 divided by the 2. When you cross multiply, you get 2 times P equals 45 times the cube root of 9. So then P is going to be 45 cube root of 9 all divided by 2. When you put that in the calculator, you get P is equal to 46.8 centimeters. All right, here's number 20. It says similar solids X and Y have a surface area ratio of 16 to 45. If the volume of X is 315 cubic meters, what is the volume of Y? We acknowledge that the surface area ratio is 16 to 45, and of course surface area is two-dimensional. We want to get the one-dimensional ratios, which is the side ratios, so we take the square root of the 16 and the 45. We end up with a side ratio of 4, because the square root of 16 is 4, and then square root of 45 is on the bottom. So the side ratio is 4 over square root of 45. Now to get the volume ratio, volume is three-dimensional, so we take the one-dimensional ratio and cube everything. So 4 cubed goes on the top, and the square root of 45, all cubed, goes on the bottom. So 4 cubed happens to be 64, and then on the bottom we just leave it as square root of 45 all cubed. We now can set that equal to the volume of X being 315 divided by the volume of Y, which is what we're trying to find. When you cross multiply, you get 64 times Y equals 315 times the square root of 45 all cubed. Now we'll just divide by 64 on both sides and put this in our calculator. So that's 315 times the square root of 45 all cubed divided by 64 gives us this final answer of 1485.762, and this is meters cubed. All right, here's number 23. It says the diameter of the circle is 24 centimeters. Find the length of the arc CD. Well, first of all, since the diameter is 24, the radius must be half of 24, which is 12. We use the arc length formula. The arc length is the degree measure of 60 divided by 360 times 2 times the radius of 12 times pi. Multiplying the 2 times the 12 times the 60 and then dividing by 360, we get the 4, so it's 4 pi centimeters. And then if we include the pi in the calculation, it's 12.57 centimeters. That would be the arc length of CD. All right, number 24, it says the length of arc EF is 5 pi. Find the length of the radius. Well, we'll start with the formula. Arc length is the degree measure over 360 times 2 times the radius times pi. Then we plug in the information. We know the arc length is 5 pi, and we know that the degree measure is 30. Now we can get everything on one side to solve for r. So we'll have to multiply by 360, then we'll have to divide by the 30 and the 2 and the pi. So that's radius equals 5 pi times 360, all divided by the 30 times the 2 pi. You see that the pi's will cancel each other out. And then when you multiply the rest, that's 5 times 360 divided by 30 times 2 on the bottom, we get radius equals 30. Number 25, find the shaded sector area. The formula for the sector area is degree measure divided by 360 times r squared pi. The degree measure is 135 and the radius is 8. When we multiply that out, multiplying everything except for the pi, that's 135 times 8 squared divided by 360, we get 24. So our final answer is 24 pi. and that is square meters. If we want the decimal answer, that would be 24 times pi, or 75.398 square meters. All right, here's number 26. Find the shaded sector area. Now the shaded area, the sector area, is the angle measurement, and this time it would be in radians, not degrees. So it's the angle in radians divided by 2 pi instead of 360, because we're in radians, times r squared pi. Now the angle given is 8 pi over 9 over 2 pi, and the radius is 4. The 2 pi's will cancel each other out here. And then when you multiply the 4 squared times 8 divided by 9, and then divide all of that by 2, the fraction comes out to be 64 over 9, and that's times pi. And then if you want the decimal answer with pi in the calculation, it would be 22.340, and that's square inches. All right, here's number 21. It says to find the circumference of this circle. First, we acknowledge that this missing angle over here is 150, and we get that by subtracting the 210 from 360. Now we can use a ratio. We know that the arc length of AB is 16, and that ratio, that number 16 divided by the entire circumference of the circle, should be equal to the same ratio as the degree measure out of 360. So once again, the arc length divided by the entire circumference is equal to the degree measure of that arc, which is 150, divided by the degree of the entire circle, which is 360. Now if we cross multiply, we'll get 150 times c equals 16 times 360, which is the 5,760. Then we'll divide by 150 on both sides, and we get c is equal to 38.4 centimeters. All right, here's number 28. Find the measure of arc GHI. Now GHI is this major arc going from G through H to I. We want to find the measure of this arc. Now first we want to look at this shaded area. The shaded area is 8 square meters. So what we need to do is find the area of the unshaded sector. And the area of the unshaded sector is the full circle area minus the shaded area. A full circle is r squared pi, and the radius is 3, so that's 3 squared pi. Take away the shaded area of 8. 3 squared is 9, so that's 9 pi minus 8, and that represents the area of this unshaded sector. Now we can set that equal to the formula, so the sector area is the degree measure divided by 360 times r squared pi. The sector area, unshaded sector area, is 9 pi minus 8, and we also replace the r with 3. Getting the degree measure by itself, we'd multiply both sides by 360 and then divide by 3 squared pi, which is 9 pi. So the degree measure is 360 times 9 pi minus 8, all divided by 9 pi. Putting this in the calculator, we end up with degree measure being 258.14 degrees. So that is the measure of the arc GHI. For number 29, it says find the measure of the arc ST. Now first we can find the arc length of ST because we know the arc length of the major arc is 41. So the arc length of ST would be the circumference minus the arc length of 41. The circumference is 2 times 9 times pi, or 18 pi, and then subtract the 41 from that. So the arc length of ST is 18 pi minus 41. Now we can use the arc length formula. That is the degree measure divided by 360 times 2r pi. And then replace the arc length with 18 pi minus 41, and also replace the radius with 9, and 9 times 2 would make 18. Solving for the degree measure, we would multiply both sides by 360 and then divide by the 18 pi. So the degree measure is 360 times 18 pi minus 41 over 18 pi, and that comes out to be about 99 degrees. All right, number 30, find the measure of arc CD. Well, first, the unshaded area is going to be equal to the shaded, the full circle area minus the shaded area. And the full circle area is r squared pi, or 3 squared pi, minus the shaded area of 24. That simplifies to 9 pi minus 24. So now this unshaded area is 9 pi minus 24, and we'll call the degree measure theta. Now we plug this into the sector area formula. Sector area is degree over 360 times r squared pi. Replace the sector area with 9 pi minus 24, and r is 3, so 3 squared becomes 9. We need to get theta by itself. So the degree measure theta is 360 times 9 pi minus 24, all divided by 9 pi. We put this in our calculator and we get the degree measure is 54.42 degrees. Okay, for number 31, it says find the measure in radians of the central angle of an arc whose length is 14 pi and has a radius of 18. So we're trying to find theta in radians, that is the arc measure in radians. Now the arc length is equal to the arc measure times the radius, that is the formula in radians. The arc length can be substituted with 14 pi and the radius is 18. Dividing by 18 on both sides, we get that the arc measure is 14 over 18 times pi, and 14 over 18 reduces to 7/9. So the answer is 7/9 pi radians. All right, here's number 32. It says the circumference of the circle is 60 pi. Find the measure of arc MO in radians. Now we can look at this proportion. It is true that the arc length of MO divided by the arc length of the entire circle, which is the circumference, is equal to the measure of MO divided by the measure of the entire circle. And the arc measure of an entire circle is 2 pi in radians. So arc length of MO over the circumference is the measure of MO over 2 pi. Now the arc length was given to be 20, and the circumference is 60 pi. That was also given. And that's equal to the measure of MO divided by the measure of the entire circle, which is 2 pi. Now we just multiply by 2 pi on both sides to solve for the measure of MO. So the measure of MO is 2 pi times 20 divided by 60 pi, and the pi's cancel out. So then you'll multiply 2 times 20 and divide that by 60. So that gives you 40 over 60, which reduces to 2/3. So the answer is 2/3 radians. All right, for number 33, it says find the radius length of a circle with a sector area of 9 pi square centimeters and a central angle of pi over 6. So we use the sector area formula. Sector area is the degree measure or the radian measure over 2 pi times r squared pi. So the sector area would be the radian measure of pi over 6, because that was given, over 2 pi times r squared pi. Replace the sector area with 9 pi because that was given. And then we just rearrange the equation to isolate the r squared. So r squared would be 9 pi times 2 pi divided by pi times pi over 6. Now these two pi's cancel out, and these 2 pi's cancel out. So then you end up multiplying 9 times 2 and dividing by 1 over 6. That comes out to be 108. So r squared is 108. Then we take the square root of both sides, and we get the square root of 108. We can simplify that to 36 times 3, and then the square root of 36 is 6, with the radical 3 left over. So the radius is 6 radical 3. All right, for 34, the arc length of PQ is 10 pi with a radius of 16. Find the sector area bounded by arc PQ and its radius. So the goal is to find theta. Now to find theta, we use the formula arc length is theta over 360 times 2r pi, and then replace the arc length with 10 pi that was given, and also replace the radius with 16 that was given. Getting theta by itself, we would be multiplying the 10 pi by the 360, and we know that 2 times 16 is 32, so we would end up dividing by 32 pi. These 2 pi's will cancel out, so in our calculator we're doing 10 times 360 divided by 32, so the degree measure is 112.5. The sector area is the degree measure over 360 times the radius squared times pi. And that's ultimately what we're trying to find, is this sector area. So we do 112.5 degrees over 360 times 16 squared. We put that in the calculator, we get the 80 pi. So 80 pi is our answer. Okay, for number 35, it says convert 340 degrees to radians. We use the proportion that 340 out of 180 is equal to x radians out of pi. Then we'll cross multiply, or really just multiply by pi on both sides. So x would be 340 pi over 180, and then reduce the 340 over 180 to become 17/9. So our answer is 17/9 pi. Okay, for number 36, we are converting negative 215 degrees into radians. Using the proportion, you take the negative 215 degrees, put it over 180, and that is equal to x radians over the pi. We'll multiply by pi on both sides to get x by itself. So x is negative 215 times pi over 180. And then let's reduce the fraction. The 215 over 180 reduces to 43 over 36. So our answer is negative 43 over 36 times pi. For 37, we're converting 2 pi over 7 in radians to degrees. Using the ratio, where we just put the radian value over pi and is equal to x degrees over 180, then you'll just multiply by 180 to isolate the x. So x is 2 times 180 divided by 7. That's because these 2 pi's cancel out. So you just have the 180 times 2/7, and that's going to be 51.43 degrees. And for 38, we're converting 17 pi over 12 in radians to degrees. Using the ratio, the proportion 17 pi over 12 is divided by pi, where x degrees will be divided by 180. The 2 pi's will cancel out, and then you'll end up multiplying by 180 on both sides. So x is equal to 17 times 180 divided by 12, and that comes out to be 255 degrees. All right, that concludes the review for the Unit 2B test.